Hello everybody, welcome back to another episode of Big Brain Energy, where today we'll be talking about neural engineering and new breakthroughs in the industry.
Today's topic is focused on brain-computer interfacing for gaming.
What on earth are brain-computer interfaces, also known as BCIs? Generally speaking, a BCI is any interface between a computer and a brain. Shocking, I know, but it really is that simple. Even considering mechanical instruments like a keyboard is still a way for our nervous system to interact with a computer. Some examples include interfaces directly on the brain, like ECOG, or devices on the scalp, like EEG. Or even something as simple as eye-tracking cameras that can interpret blinks and optical gestures.
This is an important topic to consider in today's society because there's a huge market. The gaming industry is massive, having generated over $185 billion globally just this year. It has eclipsed the movie industry and is projected to keep growing into the 2030s. Furthermore, developing technology along this line of research is something that has been captured the public imagination for a long time. So it just makes sense that there is going to be an increasing interest in these devices.
However, we have to be aware of the current gaps that do exist within the research. For example, researchers are struggling with how to accurately measure brainwaves and activities, especially when using non-invasive technologies. So it comes down to mostly the software algorithms for decoding still needing some work.
EEG, which is non-invasive, and ECOG, invasive, are some devices that are currently being used to record neural activity. Although they are good for capturing electrical signals from the brain, the process is often hindered by different forms of noise that might impact the accuracy of the recordings. Another important issue is the variability between individuals. Questions like, are all brains made equal, and do we need to calibrate and customize for individuals should also be considered.
There's been some success with relatively simple games such as Tetris, Pong, Tug of War, and even Football Simulator. These games could be played cooperatively or competitively, which is interesting having competing brains wired up.
One example project is BrainNet, a University of Washington 2019 project where 3 people team up to play a Tetris-like game just by using their brains. 2 of the participants send signals about whether to rotate the blocks, while the third one receives those signals through magnetic stimulation setup, so they can make decisions without talking. It's a wild experiment that shows how our brains might work together in the future, and they even managed to get an impressive accuracy rate of over 81% in their trials.
ECOG is generally not preferred for gaming applications compared to EEG due to its invasive nature. Additionally, EEG systems have become increasingly sophisticated with advancements in technology, enabling effective brain signal acquisition.
It suggests that the more data we have, the better gameplay we will have. The location of the electrodes matter a lot as well. These electrodes are the things that go outside of the head to be able to capture these brain activities. So when using EEG for BCIs and control games, it is essential to focus on areas that are most relevant for effective control and interaction. For example, the front part of your brain is involved in decision making, while the back part of your brain is focusing more on the visual processing, which would be very critical for games that rely on visual stimuli.
Current limitations include gathering lots of data recording interference. Additionally, some games are limited by network support requirements, only online play, and there may be lag between game actions, recording, and decoding neural data.
Additionally, BCI in the gaming industry collects highly sensitive neural data, including information about people's emotions, cognitive patterns, and mental states. If this data is mishandled, it could pose significant privacy risks, such as targeted advertising and unauthorized access to personal information.
Interesting to do, to try a different way of controlling games that would be more accessible to more people.
For first-person shooting, I think it will be easier to aim because you don't need to control your arm to control the mouse. You can just directly think about where to aim and when to shoot.
So I've seen this done before. I've done it myself, where you use a BCI headset to play the dinosaur game. With the current state of neurotech, you can't really go into more mechanically intensive or fast-paced games.
Thank you for tuning in, and we hope to see you all on our next episodes.